Welcome back to the deep dive. Today we're going to crack the code on a really interesting piece of hardware. It's the NTI ST-C6USB4K18GB-230T.
Which is a bit of a mouthful.
It is. But what it is a KVM extender. And our mission today is to figure out how this thing basically bends the laws of physics to move huge amounts of data over long distances with apparently no quality loss.
It's a fantastic engineering problem to solve, and KVM, for anyone new to the term, is just keyboard, video, and mouse. So the core idea is pretty simple. You're just extending access to your computer.
But the distance is what gets me. We're talking up to 230 feet. That's about 70 meters.
Yeah, which is massive.
Yeah.
Think like the length of 2 Olympic swimming pools end to end.
Exactly. And what's really remarkable is the signal it's maintaining over that distance. We're talking full Ultra HD 4K resolution running at 60 frames per second.
And with 4.4.4 color depth, which is key.
Yes, we'll get into that. And the real hook here is that it achieves all this using just one single CT6 or CT7 cable, the kind of thing you'd find in an office wall.
That single cable is the whole transmission medium. And to push a signal that far without it degrading, you have to manage an immense amount of bandwidth. This extender is built for up to 18 gigabits per second.
Which confirms it's fully HDMI 2.0 compliant.
Absolutely.
So that 18 Gbps is, it's not just a nice to have, it's essential for this kind of fidelity.
Yeah.
And you mentioned 4.4.4 color. Let's bring that down. Why is that specific detail so crucial?
That's a great question, because it's where you separate their professional gear from the consumer stuff. 4.4.4 means you get full color sampling. There's no compression of the color information.
Okay, so in practice, what does that look like?
Well, if you were watching a movie with, say, 4.2.0 compression, you probably wouldn't notice. But if you're looking at sharp text or fine lines in a CAD drawing or maybe a display in an industrial control room.
You'd see it then.
Oh, definitely. The text would look blurry. Maybe you have some weird color artifacts around the edges. For any application that needs precise visual data, 4.4.4 is absolutely essential.
And speaking of precision, the specs claim 0 latency. That feels like a huge claim. Is that truly 0, or are we talking 0 perceptible delay?
It's almost always 0 perceptible delay for a human user. I mean, they're likely using a technology like HDBase to transmit the raw HDMI data with very, very minimal processing time.
Right, because any lag would just kill the user experience.
It would make it unusable for interactive work.
Yeah.
And beyond the latency, the whole video feature set is it's robust. It handles HDCP 2.2 for copy protection, so your 4K content will play. It supports HDR10 36-bit deep color.
The audio seems pretty flexible, too. Not just the standard HDMI embedded audio, but I see the remote unit has its own dedicated SPDIF digital audio output.
Yeah, that Toslink port. It gives you options. You could feed a separate audio system that's all the way at the other end of that 230-foot run, far away from the source computer.
Right, but the KVM side of it is where things get really compelling for certain applications. It's not just about viewing anymore.
Exactly. It, of course, supports your standard USB keyboard and mouse, and they're hot pluggable. But the documentation specifically calls out support for USB touchscreen monitors.
And that's where it gets really interesting. That means this is for full interaction, not just passive viewing. You could have an operator controlling, say, a manufacturing line from a clean room 100 feet away.
That two-way communication is key. The USB standard is 1.1, so it's perfect for those low-speed input devices like touchscreens or a mouse.
So the whole architecture is pretty straightforward then. A local unit by the computer, a remote unit by the display.
Yep. And the local unit even has an HDMI loop out, so a person at the source can see what's being sent. It's just a seamless bridge, and it works with Windows, Linux, macOS, anything.
So to sum it up, the real value here is bridging that 230-foot gap for really high-end 4K control systems with what is, for all intents and purposes, 0 loss. It solves a distance problem that normal cables just can't.
It does. But that brings up a really interesting final point for you to think about. While the CAT cable solves the 230-foot problem, you still have to connect your computer to the local unit and your display to the remote unit.
With standard interface cables.
Right. And for 4K video, a passive HDMI cable is really limited to maybe 20 feet, if you're lucky. So you solve this massive distance problem in the middle, but you still have to carefully manage the much shorter connections right at the endpoints.
A perfect final nuance to consider. Something to keep in mind when you're designing the whole system. Until next time, keep diving deep.